Hey, it's me again. Today we're going to talk about factoring special products. And the way I would teach this in class is have a warm up. And I would ask you to multiply the following expression. So I want to multiply a plus 3 times a minus 3. Well, consider the two options that we've always used. Let's look at the FOIL method. I would take a times a, and I would get a squared. And then I would take a times negative 3, and that multiplies to negative 3a. I would take 3 times 3a, and that would be a positive 3a. And then when we multiply 3 times negative 3, we get negative 9. What happens here? What happens is the outer product and the inner product would combine to give me 0. I would be left with a squared minus 9. Okay? And for those of you that prefer the box method, let's do it. All right. So when we multiply this, a times a is a squared. A times 3 is 3a. Negative 3 times a is negative 3a. And negative 3 times 3 is negative 9. And you would see here that these would zero out along the diagonal. I'm left with a squared minus 9. So notice, whenever we multiply these out, we get a binomial in both cases. Well, we get the same answer, but that same answer is a binomial, okay? And there are a few other things you should notice. This answer is the result of a times a, of squaring a. This answer is the result of multiplying negative 3 times 3. So a times a is a squared, negative 3 times 3 is negative 9. Think about that for a second. Now let's look at 5x plus 7 times 5x minus 7. Let's do the same thing here, and let's FOIL this out. So 5x times 5x is 25x squared. 5x times negative 7 is negative 35x. 7 times 5x is positive 35x. And then 7 times negative 7 is negative 49. What happens? We zero out. We're left with 25x squared minus 49. Now, let's go ahead and box that up. And when we do that, we take 5x times 5x, and that's 25x squared. 5x times 7 is 35x. Negative 7 times 5x is negative 35x, and negative 7 times 7 is negative 49. And this is so cool because these will go out. And we're left with 25x squared minus 49. And here's what I want you to notice. I get two terms, and then I have 5x times 5x is 25x squared. I have negative 7 times 7 is negative 49. So in both of these, what do we get? We get a binomial because those are two terms. What else do you notice about them? Well, they both have a subtraction involved. And what is the result of a subtraction problem? It's called a difference. And what is it that we're subtracting here? Well, a squared is a square. 9 is a square. 25x squared is a square. 49 is a square. So we call these a difference of squares. And just to throw a little more vocab at you, this is the result of multiplying conjugates. Oh, Robadeer. okay? Conjugates are numbers that they're binomials that have the same terms, but opposite middle terms. 8 plus 3, a minus 3. 5x plus 7, 5x minus 7. Okay, so that would be my warm-up for you before I handed out the notes. Oh, how convenient. They're right here. Okay, a difference of two squares. Notice again, square minus square. A difference of two squares is an expression where two squares are subtracted. So you create it by multiplying two binomials with the same term. One is addition, one is subtraction. And those are known as conjugates. Okay? So to identify a factor of two squares, find the square root of each term and then write them as a conjugate. Okay, so look here. X squared minus 49. What do you square to get x? Oh, I'm sorry. What do you square to get x squared? You square x. See that minus? What do you square to get 49? 7. So this is x plus 7 times x minus 7. All right, let's look at the next one. A squared minus 100b squared. What do you square to get a squared? A. What do you square to get 100b squared? Well, the square root of 100 is 10. The square root of b squared is b. Holy cow, she's going back to Unit 1 and what we had to do with squares. Yeah, she is. So this is a minus b. I'm sorry, a plus b. Oh, a plus 10b times a minus 10b. All right, take a minute and look at the next one. Is 25y squared a square? Yeah, it is, Robodeer. It's the result of squaring 5y. See the minus? All right, what do you square to get 16? 4. So this becomes 5y plus 4 times 5y minus 4. All right, x squared, x to the fourth minus 36. That one may be a little daunting. Is x to the fourth a square? Yes, it is. And I know it's a square because it has an even exponent. What do you square to get x to the fourth? You square x squared. Bring down the minus. What do you square to get 36? 6. So when we do this, the factorization is x squared plus 6, x squared minus 6. All right, y'all seem to be holding up okay. What you need to notice is that whenever we do these, you look for a difference of squares. A difference of squares is two terms separated by subtraction, and those two terms must be squares. So if this were x squared y squared minus 6, there's nothing you could do with this because 6 is not a square. X squared y squared it's the square of xy. It has to be a difference. And then what's the square of 4? Or, I beg your pardon, what do we square to get 4? 2. So when we factor this, it's xy plus 2 times xy minus 2. All right. What do you square to get 36c to the 6th? That's easy. That's 6c to the 3rd minus, all right, what do you square to get 121? 11. And what about x squared? Well, that's just the square of x. So this will factor to 6c plus 11x times 6c minus 11x. Remember now, way back in the day, I gave everybody a sheet of paper in your folder with a bunch of squares. They're on Google Classroom somewhere. And I asked y'all if you wanted your folders, that I would deliver them to you. Out of my 67 students, one of you asked for it. So one of you has your list. Hopefully the others of you found one, or you know your squares, I hope. All right. So you'll see that sometimes if you Google this and they ask you how does it factor, here's what's always going to happen. They're going to write this as, they'll say a squared minus b squared equals a plus b times a minus b. And that's pretty much it. I have a lot of students who still don't like the variables, so I tell them it's the first plus last times first minus the last. Okay, so that takes care of the difference of squares. Now, that's always a binomial because you can only subtract two numbers at a time. And there's always a subtraction in the middle. There is no way in Algebra 1 to factor a sum of squares. That's something you may see in Algebra 2. I beg your pardon. That's something you will see in Algebra 2. Okay. Then I would have two other problems on the warm-up, but I would come back to these. Suppose I asked you to carry out this. Okay, what is it? Well, this is really y plus 4 times y plus 4. And if we were to FOIL, y times y is y squared. Y times 4 is 4y. 4 times y is 4y. 4 times 4 is 16. Uh-oh, nothing zeroes out here. But notice I have identical terms here. Okay, so when I combine like terms, I would get y squared plus 8y plus 16. What would it look like in the box? Well, in the box we would have y times y is y squared. Y times 4 is 4y. 4 times y is 4y. 4 times 4 is 16. And notice these are the same thing. We get y squared plus 8y plus 16. So notice again, I'm getting squares on the outsides. All right, think about that for a second. Let's look at another. Let's look at, oh dear, here she goes. Y squared minus 4. Almost the same problem, except instead of adding y and 4, we're subtracting. So let's expand this. It becomes y minus 4 times y minus 4. Y times y is y squared. Y times negative 4 is negative 4y. Negative 4 times y is negative 4y. Negative 4 times negative 4 is positive 16. And again, I have my like terms in the middle, just like in any other problem, if that were to occur. So I get y squared minus 8y plus 16. And you know, way back in the day, in Unit 1, when we discussed this, I told you it would help you to have a shortcut. And so I'm going to show you how that shortcut works. I'm not going to box this one, you get the idea. So if we were to expand this in order to simplify it, again, we would get 2c times 2c is 4c squared. 2c times 9 is 18c. 9 times 2c is 18c. 9 times 9 is 81. So my like terms here are 18c plus 18c, and we would get 4c squared plus 36c plus 9. All right. Let me go and do the last one, and then we'll look at the shortcut, and you'll say, oh my goodness. And you'll see the whole reason that I love algebra so much. Because again, it's about patterns I don't sell it as patterns. I sell it as shortcuts because remember, this is an instant world. You want everything right now. So I'm going to show you how to get it right now. Pardon my mess up there. Okay, 3f times 3f is 9f squared. 3f times negative 11 is negative 33f. Negative 11 times 3f is negative 33f. And then negative 11 times negative 11 is positive 121. All right, look here. I have like terms again. So we'll get 9f squared minus 72f plus 121. All right, you ready? Oh, this is so exciting. Shortcuts. Let's look at them. What is y times y? Y squared. What is 4 times 4? 16. What's 4 times y? 4y. Well, it showed up twice, so we double it. Boom. That's what I got over there. Okay, let's do it again. What's y squared? Y squared. What's negative 4 squared? That's negative 4 times negative 4, which is positive 16. In your calculator, guys, you want to do negative 4 squared. That way, the negative is also squared. This equals 16. Please include the parentheses or you'll get a negative number. Okay, what's y times negative 4? Negative 4y. Double it. Why did we double it? Because we wrote it twice. That's what doubling means, right? Twice. Okay, what's 2c times 2c? 4c squared. What's 9 times 9? 81. What's 2c times 9? 18c. When we double that, we get 36c. Oh, look. 3f minus 11 squared. What's 3f times 3f? 9f squared. What's 11 times 11? 121. What's 3f times negative 11? Negative 33f. And when we double that, we get negative 66f. And oh my goodness, what in the world, Robadeer? That's negative 66. Oh goodness. All right. So aside from that ridiculous mental blunder, let's go back and look at the notes now. All right, to factor a square trinomial. Now, remember, algebra people love to throw variables in and make patterns. And that's sort of what we did here. A squared minus 2ab plus b squared, or a squared minus 2ab plus b squared. Square the first, square the last. Multiply them and double it. That's what I did. Square the first, square the last, multiply them and double it. Same idea, okay? So that's what's going to happen down here. I'm going to completely undo what I just did over there, okay? What is this? What do we square to get x? Well, we square x squared. What do we square to get 25? We square 5. Okay, what's x times 5? 5x. Let's double that. So we're going to take 2 times x times 5 to get 10x. Is that middle term? Yes, yes it is. So this is x plus 5 squared. Okay, that might have been a little fast for you. Let's see if we can look at this again with the next one. All right. D squared is the result of squaring D. 81 is the result of squaring 9. All right, go off to the side. What is 2 times D times 9? That's 18D. Does that match the middle term? Yes, it does. So this is going to be D plus 9 squared. All right. I hope you're getting the hang of this. And again, you have to do a whole bunch, one behind the other, to sort of establish the pattern, i.e. the shortcut. All right. What is this? What do you square to get n? Squared. You square n. What do you square to get 144? You square 12, right? Okay, now notice there's a negative in here. So we're going to take 2 times n times 12. We get 24n. Is 24n negative 24n? Nope. What does it need? It needs a minus right there. So this is n minus 12 squared. All right. What do we square to get 9s squared? We square 3s. What do we square to get 16? 4. Okay, so let's look at it. Let's take 2, I'm going to put it right here, 2 times 3s times 4. Okay, when we multiply that, what did I do? Oh, yeah. This is 24s. Is that 24s? No. So guess what? This is not factorable. It doesn't match. The middle doesn't match. And guess what? This one was a happy accident. I know it was. Had the variables matched, it would have been factorable. But that's actually a good lesson. It's a lesson for me to proofread before I print out. But it also shows you that you have to make sure every number and every letter is the same. Okay, let's look at 36r squared minus 12r plus 1. This is the result of squaring 6r. This is the result of squaring 1. So when we do that, let's look at 2 times 6r times 1. That's 12r. And notice this negative comes along. So this is going to be 6r minus 1 squared. Okay. The last one. As I'm changing colors, you're going to ask yourself, what if I can't recognize the squares, Robadeer? I would say that's perfectly okay. Remember what we did last week, splitting the middle and using the box method? It applies here. Aren't these trinomials? So guess what? You can do the same thing there. In fact, you can do the ones above there, but we're not going to get into that today. All right, 100x squared is the square of 10x. 9y squared is the square of 3y. All right, so let's go off to the side here. When we take 2 times 10x times 3y, we get 20 times 3. We get 60xy. Oh, that works. So this is 10x minus 3y squared, because remember, that negative has to come over. So those are the notes. I did want to look at a couple of these in the practice, namely, well, let's look at number 4. Here's what you do. Count the terms. There are 2 terms. It's a binomial. Are those 2 terms being subtracted? Yep. This is a difference of squares. So guess what? This is the square of 2r. This is the square of 5. So because it's a difference of squares, this factors to 2x plus 5 times 2r minus 5. All right, look at this one. This is the square of p. This is the square of 1. Robadeer, you don't even entertain that. Don't even go that far, because look, there is no such thing as the sum of squares. There is nothing you can do to get p squared plus 1. Well, in Algebra 1, there's nothing you can do. When you get to Algebra 2, oh my goodness, that opens up a whole nother can of worms. All right, so that's how you would look at a difference of squares. And I gave you 18 of those to kind of look at. And then we get to something like, look at number 22. This is the square of r. This is the square of 3. It's a trinomial, so I'm in the right step. This is 2 times r times 3. That's 6r. Is that what that is? Yep. So guess what? This is r, bring over the minus, 3 squared. Okay, so that's what's going on here. And then that should help you get a little more practice, do the rest of the practice problems, look it over, and then you've got your ICC.